Hi, this is Simon. Welcome to our second circuit bending video, where I'm going to dig a little bit more into this magic wand here. A couple updates from the last video. I, in the end, decided to put back together the whack-a-mole and give it to my kids to play with. They've been having a great time with it. The noises drive me crazy, but at some point I'll take out the batteries. Also, after last video, I managed to get the keyboard working. I'm not really sure how. I just put the batteries back in again, and it was working. I did record a video of that, but I didn't have my microphone going, so I'll probably cut in a clip right here with just the camera audio. But for today, we want to keep going with this Tinkerbell wand that we found. I want to clarify a few things that I brought up in passing about electronics from the last video. I want everyone to be clear that I am a composer, not an electrical engineer. I know enough about this stuff to have fun, but if you want to learn proper electronics, this is not the place. If you want to have fun misadventures with sound design, then this is a better place for that. So, I don't have many new tools today than I did last time. I have my screwdrivers. I do have a pair of wire cutters, which we'll put to good use. I also, around me, I have some resistors, I have some variable resistors, some pots, I have some thermistors and LDRs, and we have a few things that we can experiment with as we look at this and we decide what modifications we want to make. I'm going to start by zooming in. Let me be a little bit more clear about components. Again, I'm not an electrical engineer, but I do know how to recognize resistors. Why, when I was opening this up, I said, oh, look at those resistors. And especially these kinds of resistors are easy to spot, they're easy to read, unlike the surface mount resistors we saw in the whack-a-mole. I also talked about capacitors. Again, visually, I know that this is a capacitor and this is a capacitor because I know that's what those look like. I have a guess that these two are transistors, but I'm not completely sure about that. The other thing I did last time was make a mental note of where wires that come off this board go. So for example, there are two wires here, and they go into the rod of the wand, so we know that the batteries are down there, and so we can guess that that's the power. This red and black wire are going to the LED. These two white wires are coming from whatever this trigger device is, and then these two yellow wires are going to our speaker up here. Again, an electrical engineer can tell me better. There's just sort of a resistor here in the wire that's going to the LED. That doesn't seem like good practice to me. I don't know. Again, I'll ask someone who's a better electrical engineer, but it seems that they realized they had a mistake and so they had to add this on. This seems like it would be more expensive to put things that way, but who knows. Last time, I identified this resistor as our clock resistor, and that was just through poking around in the sound. So let's turn this back on again, remind ourselves what it sounds like. There it is. Okay. So what I have here is a 10K resistor that's on two jumper cables. So then 10 kilo ohms. And I clip that on either side there. Oops. Much, much faster. So what's happening is it's easier to go through this resistor than this resistor. So we're sort of bypassing, actually, you know, there's an equation for adding together two resistors. If I remind myself in the edit, I'll put that up on screen. But that's less important than the fact that, again, we have less resistance now along this part, and so less resistance, so the clock is going faster. Now, we can find out what the resistance of this resistor is based off of the colored lines. I have terrible eyes. I looked at this before the video, and I looked it up on a chart. I believe this is a 560K resistor. So 560 kilo ohms. Ohms is our unit for resistance. So if I've been using a 10K to bypass that, this is significantly less than 560, right? 10 is less than 560. And so we're able to go much faster. One of the things we talked about last time is I can't make this clock go any slower without increasing the resistance. And I can't increase the resistance by just running things in parallel. If we think about that for a second, the reason is if we put something next to it that has more resistance, the current will take the route through this 560K resistor, which is easier to pass through. So I'm gonna start by, we'll see how this goes, but what I'm actually gonna do is I'm just gonna cut one leg of this resistor. And I'm gonna try to leave enough on either side. Okay. If I turn this on now and I try to trigger it, nothing's happening. It's because I've just disconnected that clock resistor, which is necessary. Now, just to try something out, let's now clip our lead. Again, we've still got this 10K resistor. I left just enough of that leg to clip on there and to clip on here. Oh, come on, friend. It's hard to grab onto. Turn it back on. I don't know how good your musical memory is, but that's just slightly lower. I'm gonna zoom out a hair. So now let's think about this. We have our 560K resistor, but then in addition, because now they're no longer wired up in parallel next to each other, they're wired up in series. So now we have a resistance of 570. Okay, that's kind of neat. Let me reach over here though, and instead of using that resistor there, let's throw in a variable resistor, potentiometer. Clicking the yellow to the middle and the red to one of the edges. Okay, let's see how we do. It's hard to hold multiple things at once here. Okay, so let's think about what's happening there. Still, whoops, I've just knocked it off. But still, we have our 560K resistor here. And now this potentiometer that I've added, if I've been keeping things in the correct bags, this says this is a 500K. So that means this variable resistor, as I turn it, it can have as little as 560, again, the original resistor that I've knocked off again, and as much as 1060. Okay, so that's neat. So one thing that I could potentially do is maybe drill a hole in the back of this wand, have a knob that comes out of it, and then I would be able to shake the wand and it would make a note, and then as it made the sound, I could change the pitch. All right, let's say goodbye to this guy for a second. Now, it's all about resistance, so it doesn't really matter how I do that resistance. So this is a light-dependent resistor. So again, I'm trying my best not to knock that off. I've done this in kind of a silly way for the moment, but okay. I've just realized my hand is out of the shot there. Let me zoom out of here. Sorry, I apologize. So I've clipped in this light-dependent resistor, just one clip on each leg. I'm gonna put my hand over it, so less light. Probably this at its maximum doesn't offer as much as 500 kilo ohms of resistance. I'm gonna reach over and grab another jumper cable here. I don't actually know off the top of my head how much resistance this LDR can offer. But again, it's being added to the 560 that I have clipped in there, but I can also take this, again, I'm clipping it into the green, bink. Oops, where'd those go? And then green goes to another one, which then goes to our yellow. So now I've run these LDRs in a series. As it gets darker, more resistance, lower pitch. So that's kind of neat. All right. Let's see how this one goes. What I'm taking out now is a thermistor for heat. I have a silly little piece where I use hot coffee and iced coffee to control a thermistor running through an Arduino. Let's clip this in and let's get a way to warm that up. Again, being very careful, but still. I'm unimpressed with the results there. I'm not completely sure why, but it might be that it's too subtle for those, but we'll just leave that be for a second. This has seen better days, but this is a pressure-based resistor. Oh, it actually seems like it decreases the resistance as I push on it. Oops. I'm not sure this is functioning correctly, but boy, that's a bit of fun, huh? This one's been in a drawer for quite a few years, so who knows if this is right, but it's definitely reactive. Okay, that's a thing. The photoresistors are always fun, but I did kind of like this knob idea. I was thinking about some other things, though. Oh, I've turned it off. There we go. I mean, we could go even further. I have 1 mega ohm resistors here. I mean, if I'd like the low sound, I could just put in it doesn't have to be a variable resistor, just a resistor in there. Turn that all the way. It sounds remarkably normal that slow. Okay, one of the other things that I was thinking about were buttons. Where are my buttons? Because once this sound starts, maybe I want to have a little bit more control over this. So here's a button. This button is, it's not a toggle, right? It's not a switch that goes on and off. It's just letting the current through when I'm holding it down. So, you know, one of the things I'm thinking about here is this wire to the speaker. So we've got 2 of them there. There's not really a great way for me to cut those and have much to work with. I might just have to cut this and then strip it with a different tool. So again, one of the wires going to the speaker. Cut. So that's just cut there. I'm not sure this will be effective, but let's see if I can strip that and get down to something I can clip onto again. Oh, maybe. I might have to replace this wire, which is okay. So just to clarify, this should be the normal circuit. The only thing I've done is I've cut this wire and then clipped that together with the green one, and then the resistor that I've cut is clipped together with the yellow. So this should be the original. Okay, so that's working. Let's get a jumper cable here. And now, what we'll do is we'll put our switch in there. What I've done is I've clipped the wires onto the switch. Now when I touch this, we can see that it's getting triggered, right? Because the LED is coming on. It's nice to have that little thing there. But now, it's not going to the speaker because the switch is off. Whoops. There it is. Don't want them touching there. Okay. I'm just going to zoom in on that switch. It's hard to see. This switch has 3 legs. The green jumper cable is on the middle leg. and the right one's on the side. So again, I wish I had an assistant here, but oh well. Social distancing. And that's working when I don't push the button because it's so tight in there that the cables sometimes touch. There we go. Okay. I'm going to reconnect the variable resistor. I'm going to where'd my 1 mega ohm variable resistor go? Oh, okay, here it is. 1 mega ohm variable resistor. Yellow. Red. Okay, oops. It's not clipped on. So what I'm doing here is I'm experimenting with different things. Again, I have some ideas about what I want to do. Hey, triggering when notes happen is good. Being able to have some control over the pitch is a good thing. And so I have those ideas in my head, but I'm just trying different things. That's a good thing about working with these jumper cables and the alligator clips is nothing here is permanent. Possibly next steps, if I make something that I like, is going to be to solder on these components. Or I could possibly use a wire wrap tool. And so that's a no solder solution. But for now, let's see how we do. Okay, let's turn that clock resistor to be really low. And so now remember, if I put this all back together in its original case, I won't be touching here, I'll be waving the wand. So now I have three sort of controls. I wave the wand, and then I can adjust the speed and pitch with this, and then I can do a sort of stuttering on effect with this. The other thing to think about is last time when I was poking around, I found some other places that produce some interesting sounds, some interesting glitchy sounds. I just sort of randomly connected a couple things on the board. We can fish around and refine those. If I were clever, I would have marked those with a Sharpie last time when I did that, but I guess I was distracted by all of those screws I had to do for the whack-a-mole. But maybe we'll poke around a little bit, see if we can find something fun. Just clip onto this, for example. I'm going to, for now, bypass this switch. So I'm just going to clip these together, and then maybe we'll turn this up to its regular. Well, no, let's keep it low for a second. Maybe I should use a different color because we already have a green. That's interesting. There we go. There's something fun. Okay, so let's say I like that sound. What I could do, I'm going to use the same switch, but you know, I obviously have multiple switches. I could cook this switch up. Sorry, I've just run out of colors here. I'm just going to do a green one there. Boom. And hook that up there. See if we got this working. And so now I have a little glitch switch. Which is an accidental rhyme, but absolutely what I would call this in a final project. So we can switch it to super slow. Okay, so unlike the clock resistor, I really don't have any idea what I'm doing. If I'm glancing through this, right? Okay, something is happening with shorting that clock resistor to the LED, but I have no idea why that makes it make this sound. But if we're looking to add controls to this instrument, this one seems really fun. So get another switch, and then I can do that stutter effect. I can have a button to trigger a glitch, and I can control the speed. Right now, this is just a mess on my table, but next I would think about how I want to put this back together. I've said before that I think I really do want to get this all back in the wand. So there's space in here to drill some holes and put those buttons through. drilling holes for these square switches. I might see if I have any some different switches I could put on. If I were industrious, I could maybe 3D print something to attach onto the one. Believe it or not, I have a whole spool of pink 3D printer PLA, so I could print something that I could attach on here. But I'm not sure that's entirely necessary. Again, I would want a more permanent solution than these alligator clips, so I'd start doing some wire wrapping and or soldering, and maybe that's what we'll get to in the next video. I'm gonna leave it here for now though. Have some fun, stay safe, only do battery powered stuff, and feel free to share what you're working on.